Hello everyone, my name is Emir Batuhan Özgenç. I'm from Bilkent University Electrical Engineering Department, and today I will talk about my Physics 102 project, which is the impedance, phase angle, and resonant frequency of an AC-powered RLC circuit. In an AC circuit, capacitors, inductors, and resistors all have some form of reactance towards flow of the current. Capacitive and inductive reactance both depend on angular frequency, but resistance of a resistor is constant, similar to a DC circuit. To combine all these forms of reactances, we will use the term impedance, which can be calculated as shown. And also, resonance is the point where impedance is lower, and the capacitive and inductive reactances are equal, and the phase angle is zero. In my experiment, I will set up the circuit here using a capacitor, inductor, and resistor with values shown here and crocodile cables. For measuring data, I will use a multimeter and a dual input oscilloscope. This is the first part of my experiment where I apply a particular voltage to the circuit and measure the current using the multimeter and the time delay and phase angle using the oscilloscope. Then I will repeat the same process for different voltages and plot the current versus voltage graph to calculate the impedance. And I will compare impedance and phase angle values with their theoretical values and calculate error percentages for both. In the end, I will repeat the same process for different frequencies. And these are the results for the first part. For different frequencies, I have obtained different impedance and phase angle values. At first glance, I can say that the error for the phase angle is generally higher. This is the second part where I am trying to find the resonance frequency by changing the frequency of the circuit until the phase angle is zero. Then I will compare the results with the theoretical value. And these are the results for the second part. Using a 100 nanofarad capacitor, a 100 microhenry inductor, and a 150 ohm resistor, I found the resonance frequency using the oscilloscope as 53 kHz, and I calculated it as approximately 50 kHz, which gave me an error rate of approximately 7%. In conclusion, I can say that the impedance is the AC analog of equivalent resistance in DC, which is the ratio of voltage over current. And also, especially from the first part, I can say that when phase angle was lower, the impedance was lower too, with the lowest possible value being the resistance of resistor when phase angle is zero. And of course, this experiment has some form of error, which I think can be caused by loose contact in the wires, poor calibration of the devices, as well as human error. And that's all for my experiment. Thank you for listening me.